Ejaz sir. Deshmukh sir, can we start?
Yes, yes.
Yes, sir, Ejaz sir. You can start. Sorry for the inconvenience. You
Okay,
can
no
start.
problem. Good afternoon, everyone. First of all, I would like to thank Deshmukh sir and organizer committee. Today, my topic is production of biodiesel and qualitative screening on thin layer chromatography by lipase enzyme. First of all, introduction. Can I visible? Hello.
Yes, sir. Your screen is visible and your voice is also
Okay.
audible.
Okay. So first of all,
Just share it on the slideshow, sir. Your PPT.
my PPT is visible.
Yes,
Yeah, not-
PPT is visible. Please put it on slideshow.
Now visible.
Yeah, PPT is visible, sir. Just keep the slides shown, no, sir.
So towards your right hand side at the toolbar,
Yeah.
you have the option.
Slideshow. Just beside the 100% number is there, no? There you have the option of slideshow.
Next previous year, right click.
No, sir. At the bottom line of your computer, you have the minimizing and maximizing option with the numbers, no? 100 plus minus 50. There you have the option slideshow. Yeah. But then now your PPT is not visible. Only your window is visible. Yes. Now it is on slideshow, sir. Thank you, sir.
Visible.
Yes. Now it's visible on slideshow. Yes, sir. It's visible, sir.
Okay.
Yeah. Thank you.
So you can start.
Okay. First of all, what is lipase? Lipase is a hydrolase enzyme that breakdown of triglyceride into free fatty acid and glycerol, and by catalyze the hydrolysis of ester bond. Lipase have many prominent applications like biodiesel, biodegradation, bioremediation, pulp and paper industry, and also detergents, pharmaceuticals. Biodiesel is a monoalkyl ester, is currently an accepted and dependable suitable for diesel. Esterification, trans-esterification, inter-esterification, hydrolysis, and other renowned reactions of lipase are only a few of many other biotransformations, potential of them which are industrial explored as a biocatalyst. And environmentally sociable procedure, the lipase used is in many industrial biocatalyst conversions. And that lipase have many prominent reactions like they say esterification, acidolysis, alcoholysis, aminolysis, thiolysis, and interesterification. Like methods. First method, the lyophilized enzyme was prepared from freeze drying of cell-free supernatant of fermented broth. जिसकी lipase activity 15 mg per ml of Bacillus pancreasis lipase. In this research, the lipase was utilized as a biocatalyst in the trans-acidification reaction because lipase has many reactions like hydrolysis, acidification, trans-acidification. Lipase enzyme, the reaction combination of soybean oil and methanol produce both biodiesel and glycerol. This is a 0.6 gram of lipase enzyme, 4 ml methanol, 16 ml soybean oil, 25 of intubations, temperature 50-50 and RPM 150. Trans-acidification reactions की soybean oil plus methanol, this is a reactant, and lipase enzyme powder used as a biocatalyst, and product glycerol and FAM, fatty acid methyl ester. And second method, immobilized lipase enzyme. So I used Candida atacica as a biocatalyst with the soybean oil. The Candida atacica was brought sigma aldic, methanol was purchased from high media, and edible grade soybean oil was brought from nearby food store. In second method, immobilized Candida atacica lipase was used as a catalyst for biodiesel production from soybean oil and methanol. In this condition, the lipase efficiency transferred soybean oil with methanol to produce biodiesel, giving an overall conversion of 98%, temperature 50, incubation duration 24 hours, RPM 120, and butanol 6.5 ml. So trans-acidification reaction is soybean oil plus methanol, and this is a reactant, and immobilized lipase enzyme used as a biocatalyst, and the product fatty acid methyl ester plus glycerol. And third one is soybean oil hydrolyzed with bacillus stachynosis. In third method, the bacillus stachynosis lipase 1.5 ml was used to hydrolyze the soybean oil into free fatty acid, and free fatty acid mixture was then separated to acid catalyzed sulfuric acid esterification reaction using methanol as the alcohol source to produce biodiesel. Incubation time 48 hours, 150 RPM, heated to 40 degree, and then centrifuge 1000 RPM for 10 minutes. In 10 minutes, and this is the hydrolysis, and triglyceride plus 3H2O. Lipase enzyme was used as a biocatalyst, and then glycerol plus free fatty acid. And second, esterification, free fatty acid plus methanol, acid catalyst. This is the H2SO4, sulfuric acid, and product fatty acid methyl ester plus H2O. And fourth, lipase activity measurement. The PNPP para-nitrophenol palmitate is a substrate for para-lipase activity. We can determine enzyme activity by para-nitrophenol palmitate. This is a stoichiometric method. Solution was 30 gram of PNPP was dissolved in 10 ml of isopropanol, 0.05 molar pH 8.5, 0.1 milliliter of culture supernatant was added to 2.4 milli of freshly produced para-nitrophenol palmitate. The reaction was carried out by keeping the mixture in the reaction vessel at 50 degree for 5 minutes by adding 0.1 ml of fused 100 millimolar CaCl2 for reaction termination. The reaction was stopped and the tube was kept on ice. To clarify the solution, the reaction mixture was then centrifuged by 1000 RPM for 10 minutes. The yellow color observance was measured at 410 nanometer by spectrophotometer. Observation and results. Lyophilized powder with soybean oil is the first method. 10 microliter sample were taken from the reaction mixture. The different interval and exported on thin layer chrometography. Sampling point, the 10 microliter sample and different interval, 1 hour, 3 hours, 6 hours, 24 hours for TLC observation. TLC analysis 10 microliter sample of exported on TLC plate, and then plates were dried in air and kept in TLC jar. Analysis. So I used solvent petroleum ether, diethyether, and acetic acid. 85:1:5:1. The plates were developed in iodine chamber and observed for the spot of biodiesel. And TLC results observed the for biodiesel after 1 hour, 3 hours, 6 hours, 24 hours. Same spot. Fatty acid, methyl ester, biodiesel spot did not appear on TLC plates from method first. Methyl sterate was spotted as a reference biodiesel. Methyl sterate was a fatty acid methyl ester, standard methyl acid ester. Control. In control, enzyme was not added, but condition was the same as for the test reaction. And second method, immobilized lipase method, Candida hepatica with soybean oil. 10 microliter samples were taken from this reaction mixture at different interval and exported on the thin layer chromatography with the help of capillary and observed TLC 10 microliter sample and different intervals 1 hour, 3 hours, 6 hours, 24 hours. TLC analysis for biodiesel production. 10 microliter sample exported on the TLC plates and the plates were drained into air cells. Analysis. I used petroleum ether, diethyether, acetic acid 85:1:5:1. The plate developed in iodine chamber and observed for the spot of biodiesel. TLC results. 10 micro spot on TLC results and observe the spot of biodiesel. Same fatty acid methyl ester biodiesel spot on TLC plate. Methyl ester was spotted as a reference biodiesel. After 20 hours, same spot appeared on TLC plate from method 2. Control. In control, enzyme was not added and other conditions were the same as for the test reaction. This is the results of TLC. Any first results है first second. S जो है S where standard immovable enzyme Candida hepatica, and L lipolysis lipase enzyme powder, and CA control. After 6 hours and 24 hours, same spot was appeared on TLC plate. You can see I am visible. I am a hello.
Yes, sir. Yes, sir.
Yes, sir.
You are audible.
After 6 hours and 24 hours, same spot was appeared, and right side E standard. This was methyl sterate. This is the same spot on 24 hours and 6 hours. And first method and second method was not appeared on biodiesel spot. Only monoline, diolene, or triolene. When 6 hours and 24 hours spot methyl same spot appeared on TLC plate. And second and third method, soybean oil hydrolyzed with bacillus thuringiensis. The esterification reaction occurred in the presence of sulfuric acid. Catalyst from this fatty acid reaction mixture and water was produced. 10 microliter sample exported on TLC plate and observed for the spot of biodiesel. Same fatty acid methyl ester biodiesel spot appeared on TLC plate. Methyl ester was spotted as reference biodiesel spot. And third method, first TLC, the triglyceride spot on TLC, oleic acid and triglyceride. And second enzyme, oil was hydrolyzed with the help of bacillus thuringiensis, because lipids have hydrolysis property. Free fatty acids and glycerol and adjust pH acidic and release tag and triacylglyceride, free fatty acids, diolene and monoline, and centrifuge for 10,000 RPM for 10 minutes. So this is hydrolysis process. And then esterification process. Esterification process with the help of acid catalyst, sulfuric acid, and methanol. Incubated 48 hours, temperature 40 degrees, and fatty acid methyl ester biodiesel, and then determine biodiesel spot on TLC with reference. So this is reference spot and this is enzyme spot. This is dono, both spots are same. First is FAM, fatty acid methyl ester, and second is methyl ester, and that is biodiesel. So determine biodiesel spot used with different steps. Esterification process from method third. Conclusion: in the future, replacing diesel with biodiesel is a good alternative. In this study, the lipase enzyme serve as a good biocatalyst that demonstrates the action of lipid hydrolysis, acidification, trans-acidification, immobilized lipase can reduce the cost of biodiesel by taking in different types of spot like monoline, diolane, and free fatty acids and completely conversion them into FAM. FAM, fatty acid methyl ester, that is biodiesel. Good biodiesel is only considered good when its calorific value and energy value is high and its viscosity is helpful. Fatty acid methyl ester for fatty acid methyl ester using acid catalyst to speed up the reaction of free fatty acids, methanol to produce methyl ester and water, which was determined using thin layer chromatography. Diesel is a good option and used as a good parameter to good product. Some pictures are showing. First picture is separate glycerol and separate biodiesel, and second yellow bottle. This is a commercial biodiesel, and second made by biodiesel. This is made by me, and third one is biodiesel and glycerol, and third है ये एक biodiesel pump है in बीकानेर, biodiesel pump in बीकानेर, जिसमें मरुद्रा फिलिंग स्टेशन, जिसमें ये बायोडीजल के फायदे, माइलेज ज्यादा, इंजन की उम्र ज्यादा से कम, गारंटी सहित ये है. थैंक यू मैडम.
Okay, sir. I request the participants, if they have any questions, they can unmute and ask their question. Sir, you're open for the questions, right, sir?
Okay, madam. Okay.
Yeah. Sir is open for questions. So questions or any doubts, participants can unmute themselves and ask their questions.
Please, madam.
Yeah.
You can ask any question.
Yes, sir. Since the participants get ready with their questions, I have a question for you, sir. How did you produce the biodiesel, sir? What is the source of the biodiesel production?
Source is by soybean oil.
Soybean oil, okay.
Yes.
Soybean oil, and the organism is Bacillus?
Bacillus thuringiensis.
Okay. So is the production process a very tedious one, or production process is it a very tedious, a difficult process, or can we do it at the lab front for any student projects?
Any student. This is a qualitative estimation. I also worked on quantitative estimation.
Okay.
This is work only qualitative screening on thin TLC.
Yeah.
Actually, I also worked on quantitative screening.
Okay. Because biodiesel production is a very interesting topic. So we can give such topics to our undergraduate microbiology students for their projects during their last semester.
Yes.
Yeah. So soybean oil is the media. Soybean oil will be the same media also for the production? No. Actually, hello. Yes, sir. I can hear you, sir. No, they are different. Latex production and soybean. Actually, soybean oil plus methanol. Okay. This is a reactant, and then I use Bacillus thuringiensis used as a biocatalyst. Okay, sir. Thank you. Any question? No question.
Hello, sir.
Hello.
It's Bhavya this side.
Hello.
Sir, I wanted to ask a question.
Yes.
As we are going green this side, that we are producing biodiesel and bioethanol, I am also working on bioethanol production.
Okay.
So I have been using a cheaper source. So as ma'am asked that what can be the substrate for this production, as we need to go green and reduce the production cost and purification cost. So you used only synthetic media for the production of biodiesel or any other substrate like soybean oil cakes, or they also have oils, so they can
Actually,
also be used.
you are right. Soybean cost is very high. Actually, I use soybean oil. You know that soybean oil is very rate is very high.
Yes, sir.
But I use this. I use also cotton seed oil.
Cotton seed oil.
Cotton seed oil. West cotton seed oil.
Okay. So what has to be the composition of the substrate for the production of biodiesel? Means कोई specific composition होना चाहिए कि lignin ज़्यादा या lipid ज़्यादा और oily content ज़्यादा?
एक्चुअली जो लाइपेज है वो लॉन्ग फैटी एसिड पर काम करता है. यानी
Okay.
लाइपेज जो है वो दो टाइप में, एक तो लाइपेज है और एक एस्ट्रेज है. एस्ट्रेज जो है वो एक शॉर्ट चेन पर काम करता है, और जो लाइपेज है वो लॉन्ग फैटी एसिड पर काम करता है. यानी उसके लिए लॉन्ग फैटी एसिड होना बहुत बहुत मतलब नीड है. यानी जिसकी नंबर ऑफ जो कार्बन है वो 16 होने चाहिए, 18 होना चाहिए. यानी जो ऑलिक एसिड है, जो पामेटिक एसिड है, जो स्टेरिक एसिड है, वो these are needed फॉर दिस प्रोडक्शन.
ओके, तो मतलब कोई भी सबस्ट्रेट अगर हम यूज कर रहे हैं तो फर्स्ट ऑफ ऑल तो वो सीड केक्स, ऑयल सीड केक उसको
हाँ, हाँ.
प्रायोरिटाइज हम कर सकते हैं, और उसके अंदर फैटी एसिड, ओलिक एसिड का कितना कंटेंट है वो हमें पता करना पड़ेगा.
हाँ, यस
उसके बाद हम बायोडीजल प्रोडक्शन के लिए जा सकते हैं.
हाँ, यस. उसकी जो सीवी वैल्यू जो है ना मैडम,
यस सर.
उसकी जो सीवी वैल्यू है वो फिर उस पर डिपेंड करती है.
ओके, जो आपने कैलोरीफिक वैल्यू
हाँ,
कुछ
हाँ.
बताई थी स्लाइड में.
हाँ. तो
Okay,
जो वैल्यू है वो उस पर डिपेंड करती है ऑयल पे. ओके.
ओके सर, आई गेट टू इट. और एक क्वेश्चन. ओके सर, आपने इमोबिलाइज एंजाइम यूज किया है, तो हाउ डिड यू इमोबिलाइज, बाय एनी विद सोडियम आर्जिनेट मेथड?
हाँ, यस मैडम.
और
एल्जिनेट, सोडियम एल्जिनेट.
ओके सर. और कैन वी यूज क्रूड एंजाइम इंस्टेड ऑफ द लाइफलाइज्ड और immobilized enzyme?
Lyophylize means removing the water under low temperature and low pressure.
यस सर, बट हम उसकी जगह क्रूड एंजाइम यूज कर सकते हैं क्या?
Yes.
Because ultimately we need the mode of action of lipase.
Yeah, yes, ma'am.
Okay, that will give any production. वो प्रोडक्शन प्रोसेस में, प्रोडक्ट क्वांटिटेटिव प्रोडक्शन में कोई फर्क दिखाता है क्या, क्रूड एंजाइम और लाइफलाइज एंजाइम?
नहीं, उसका कोई ज्यादा कोई माइनर डिफरेंस नहीं है.
Okay, sir.
Okay. Yeah. So we have another question from another participant. Bharat is asking, what is the price of biodiesel commercial level? What is the price of this biodiesel at the commercial level?
Commercial level.
हाँ. इसका प्राइस कितना होता है सर बायोडीजल का कमर्शियल?
70 से between 80. कमर्शियल बायोडीजल.
यस सर.
पर इसमें एक प्रॉब्लम है मैडम. ये जो कमर्शियल बायोडीजल है, ये मतलब जो जब टेम्परेचर लो होता है ना,
हाँ,
तो उसके अंदर फ्लक्स वाली जो प्रॉब्लम आती है, मतलब यू कैन सी, जो मैंने अभी दिखाई थी पिक्चर के अंदर येलो बोतल के अंदर, तो वो जो बायोडीजल है वो विंटर के अंदर फ्लक्स की कंडीशन, मतलब जो आता है ना, टर्बिडिटी की प्रॉब्लम आती है.
ठीक है, तो फिर तब तो व्हीकल
तो वो
ना.
फिर वो चौक हो जाता है उसमें उसमें.
ठीक
और
है.
जो हमने बनाया ना मैडम, जो एक राइट साइड के अंदर बोतल थी, मतलब उसमें वो प्रॉब्लम नहीं है. उसमें विंटर सेशन में भी जो बायोडीजल है वो वैसे ही रहता है, उसमें कोई फ्लक्स की जो प्रॉब्लम नहीं आती है.
ठीक है, तो वो डीजल तो है ना कमर्शियल एप्लीकेशन में सर? फिर ट्रायल्स हुआ कुछ उस डीजल से?
नहीं, कमर्शियल बायोडीजल जो है मैंने परचेज किया था, वो मैंने जो बताया था ना अभी, मरुधरा जो लिखा हुआ था ना उस बोर्ड, उस पे वो मैंने उस पे परचेज किया था कि ऐसा मतलब. बीकानेर में है बायोडीजल पंप।
वो तो पक्का कमर्शियल डीजल ही है, तो
हाँ।
उसे तो गाड़ी चलना ही है।
हाँ, वो तो जैसे विंटर सेशन के अंदर वो मतलब वो चौक वो हो जाएगा, टर्बिडिटी आ जाएगी उसके अंदर।
हाँ सर। So we have another question from another participant, sir. Can we effectively use the product as cosmetics key ingredient without serious contradictions? Can we use
कॉस्मेटिक की
this? Can we use this product in cosmetics as one of the ingredient without any side effects?
कॉस्मेटिक्स लाइक व्हाट?
The participant has not asked what cosmetic he is interested in. Skincare.
स्किन केयर, स्किन केयर,
हाँ.
स्किन केयर। I don't idea. I don't have any idea.
Okay. Yes, sir. No problem. So, participants, if there are no questions, Megha, can we close the session?
I would like to answer for the question who has asked whether this biodiesel can be used in cosmetics or not.
Yes, Megha, please.
Usually, if any substance that you have to use in cosmetics should have a specific value, or they should have certain properties. If the biodiesel that we are preparing is having organic content, that is any of the solvent, and if it is not causing any harm to the skin, or if it is eligible for all the properties that are required in the skin products, then of course you can use in cosmetics. But till date, as I have read, biodiesel as such is not very prominently used in cosmetics. It all depends on what is the composition that you are having for the biodiesel that you're preparing. Thank you. Swati, you can continue.
Actually,
Yes.
I used the tetrabutanol. I used the tetrabutanol as a solvent. This is very
Okay.
harmful.
Yeah. So we have one last question, Bharat, again asking about, are there any targets for biodiesel blending from the government?
Biodiesel blending.
Yeah. Are we going to come up with some blended targets from the government? Is the government okay with the biodiesel's application and all? Maybe that's the question from Bharat.
Yes, ma'am. Actually, basically regarding bioethanol, government has some government policies regarding 20% of blending by 2025. So in the same perspective, what is the targets regarding biodiesel blending?
Yes.
My question.
Yeah,
Okay.
yeah. I understood your question, sir. Thank
Okay.
you. So you have any ideas, sir, Ajat, sir, about the government policies, how, whether they're going to accept this biodiesel or in a blended mode, are they going to accept?
40%. I
40. Yeah.
40%. 40% biodiesel and 60% diesel.
Okay.
So I used this ratio on biodiesel engine. I tried on biodiesel engine.
Okay.
40% and 60%.
Okay. Bharat, sir, I hope you got the answer for your question.
Yes, ma'am. Yes, ma'am. Thank you, sir. Thank you.
Any
So
questions?
yeah. If the participants are not having any questions, then I'll conclude the session. Megha, can I go ahead concluding the session?
Yes, Swati, yes.
Yes. So I thank our President, Dr. Deshmukh sir, for the opportunity. And then I thank our today's speaker, Dr. Ajad sir, for his valuable time and patiently answering all our questions. I thank all the participants who are the part of today's session. And over to you, Megha. Any last conclusion sentence from your end?
Yeah. So
Thank you, one and all.
yeah. So it was really a knowledgeable session where we had some technical issues at the beginning. So I would like to ask sorry for all the inconvenience that was created. And I really am thankful to Dr. Deshmukh sir, President of MBSI, and today's resource person, Dr. Ajaz sir, for spending their valuable time and making this session worthwhile. Thank you. Thank you all the members. Thank you,
Thank
Swati.
you. Thank you so much.
Yeah, thank you, sir. And now we are done with today's session and we can leave the meeting, sir.
Yes, sir.
Okay.
It was very informative and a valuable session. Thank you so much.
Thank you. Thank you.